英达就我们俩，我靠！我们的时间没搞错吧？确定是这个时间吗？怎么现在都没人了？Amazing！
怎么全是我们自己人？
不过这个已经在录了，不知道为什么。It's
嗯，
recording。
我看他们 平时是就正常情况下是下午4点冬令时的话，那对应我们这儿就是12点了。
那现在是他们下午3点了。
对，
下午3
哎，
点没
可是
毛病。
我还跟他确认过是8点啊，就是11点。
好，11点了，看看有没有人来。
你确认的时候，他们是夏令时还是冬令时啊？
哦，come in，welcome。
Hello，
Hey all. I think Justin will join shortly. I've seen him sending some messages on Slack about the meeting.
So the host is coming.
Yeah, he should be here shortly.
Okay, thanks.
Okay.
I saw that usually you have meeting like 1 hour later.
Sorry, what meeting are you talking about?
Yeah, I saw the agenda for the community meeting is usually 4 p.m. For the winter time.
Oh yeah, did we? Oh, okay, that is a good point. Like, did US move to new, like daylight saving time ended, or?
I'm not sure because we Kuvera team members lives in China and China does not have the summertime and the winter time. So actually we are not knowing what exact time are you living in.
Okay, let me check that, and I can ping Justin as well. No, it shouldn't happen now. So we are meeting at the right time, actually. Let me ping Justin. Okay, he will join. He probably has the wrong link. And he's here.
Hi, Justin. Hello. Seems we are all here.
Okay, I think now my audio is working.
Yes.
Awesome. Hello and good morning, everyone. Sorry for being late. I was sitting in a different meeting room, being like I know it's a little earlier and a little late for folks, but no one's here. Wonderful. Okay, so we don't really have other agenda items this morning, but we're just here to hear about kubevela, which I'm very excited about. I think this may be in some ways related to this intent-based pipelines thing that we've talked about a handful of times in this venue. And so I'm really excited. So without further ado, Don Fogg, would you like to tell us a little bit about kubevela?
Yeah, cool. Actually, is there anything we would like to discuss about? If not, I will go on with the presentation today.
Nothing offhand. I'm just excited to learn more.
Oh, okay, okay. Yeah, we can learn from each other. Yeah, it's actually my first time to share kubevela with people from other communities. So actually, I'm also a bit nervous, and my English is not very good. So I will try to deliver my idea as clear as possible. So if there is any questions, you can just interrupt me and we can stop there and discuss more about it. Yeah. So let's start with the presentation of kubevela today, and I will share my screen. Let me see.
Yes, and well, our meeting have a record, and I
Yes.
think we can share this record widely with people in kubevela community and both CD Foundation.
Yeah, all of the meetings are recorded and we'll send a link to you after this.
Okay, thanks.
Okay, thanks. And can you see my screen now?
I can.
Yeah, okay. So let's start with the share of kubevela today. And my name is Inda, and today I will share kubevela with my colleagues named Fogg, and we are the kubevela maintainers from Alibaba Cloud. And currently, we are focusing on building the application platform, which is the kubevela inside Alibaba Cloud. And we are trying to make it more functional and let more users to adopt it. And we are trying to continuously improving it and make it better and better. And also, I have seen that there is two other members of kubevela in the meeting room here. Is Jianbo and Yueda, and they are also from the same team. And actually, we also have a community meeting. So, but usually we only have a bi-weekly talk. So the content of our community meeting is more of incremental matters. And today it's our first time in the CD Foundation's community meeting. So I would like to share the overview of the kubevela. But there is a lot of details behind this share. So if there is, I actually do not have a general idea of what people from CD Foundation like and what you are focusing on. But since kubevela is a relatively large project, so there are many different areas we have been looking into. So if there is any specific area or techniques you would like to have more details for, actually, we are very happy to have more discussions and sharings, or even on other community meetings, we can share more details for this specific fields. So today it's I would like to just be a start for the sharing of kubevela, and I hope this can make us to cooperate in the community better, and also we can improve each other better and better. So that's a general introduction for today's share. And let's move on. So the outline of the talk today includes several parts. So first of all, I will give a very, very short description for what kubevela is. And then I will go into some details about how Kubevela works, and especially for how we design and the general principles for designing Kubevela and implementing it. And this part will contains a lot of detailed techniques. And after that, I will actually Fog will give us a demo presentation for playing with Kubevela. Actually, it's just a simple practice for using Kubevela to do the application delivery and management. So let's go to the first part. The first part. So I do not know if you guys have been looking into Kubevela from which time, but since Kubevela is developing very fast, and so even like half years ago, Kubevela has a lot of functions that today we have lots of functions that 1 year ago we do not have it completely. So so generally, Kubevela is a modern software platform focusing on application delivery. And recently, we are also adding operating capabilities for application. So generally, we are working around the application itself, about how to define applications and how to organize the applications and deliver them to multi-cloud environments. And also we focus on the day-to operating part, which means that how the application runs and if there is any exceptions for the applications. So that's what Kubevela cares about. And besides, one of the most important thing in Kubevela is that it's a program. It's organized the resources that it want to manage in a highly programmable way, which makes it very extensible and very friendly for community developers to make contributions. For example, we can make arbitrary extensions and integrations to third-party systems, as we listed here, such as the Prometheus and Terraform and other lots of open source projects. And also we are focusing on the continuous delivery part, and we have made some practices for integrating with the CI pipelines, such as Jenkins and also the GitLab or GitHub Actions. So this is a very brief overview of what Kubevela is. And then I will go on with some technical details and designs and principles for the Kubevela. Okay, so the first part of the designs is about the application delivery, which is actually what Kubevela is rooted from. So at first, the Kubevela is more of focusing on delivering application. And one of the most exciting things in Kubevela to deliver application is that we use high-level abstractions to model the application. So as you can see that in Kubevela, we have a very core unit called the application. It is designed to model a fully functional microservice unit. For example, if you want to have your own website, the website itself can be seen as an application. But to make that website works, you might need some different components. Like you might need to have some front-end service, the back-end service, and also the database to serve the data. So at this point, you can organize your application with different components, and each component will contain a running workload that provides specific functions, like the front-end service or the database. And these components are relevant with each other, and they might need to call each other to provide a full services to the customers or users. And beyond the component itself, to make those components work, usually we do not only have those running containers or pods on Kubernetes. We also have some auxiliary resources we call it trait. The operational auxiliaries includes like storage or gateway that can provide some basic infrastructure capability that helps the running workload to provide the services. So that's how we define the basic application. So all the resources and are organized into the components, and those relevant components compose the application itself. So the application is what Kubevela cares about, and the following capabilities are all working for that application. And as for the abstraction layer, we use the Qlang programming language to make abstractions. So actually, in Kubevela, there is a lot of resource templates which we call X definitions. For example, as for the web service, you might need to run some pods or containers in Kubernetes, and we usually use a Kubernetes deployment to deploy your image. And to model that running workload, we can create a component definition called web service. So the web service component definition is a Q template which accepts parameters from the application and then render it into the detailed deployment under the application. So in addition to the web service itself, we might need to add some traits to it to help it to work. Like we might need some high available services. So we may need that deployment to have multiple replicas. That's how we use the scalar trait. The scalar trait will define the template of modifying the original workload. And also, if you want to expose your service to outside, you might need some gateway auxiliaries, such as the service object and the ingress object. They can use together with each other, and these can be bundled into another trait definition, or we call some resource template. And the gateway trait definition accepts some parameters like the path and the port you would like to use, and also the underlying ingress class, and also the domain you want to connect with. So these parameters are exposed to upper layer application users. So the application layer, the application user only need to fill those exposed parameters to use the underlying gateway. They do not need to care about what the underlying resources really are. So these are managed by the Q render engine and the template. So to this point, the application user are usually application developers. They focus on the function of the application, but the definition part is more of system operators. Those guys are more of focusing on how to expose underlying infrastructure to their upper users. So by using this abstraction layer, we can make the large development team can cooperate better with the underlying operating team. Besides, the template itself is highly extensible. You can write like arbitrary rendering logic in Q language, and then you can just put it in your Kubevela system, and then the Kubevela system will be extended so that the application user will be able to connect to more infrastructure capabilities. So that's how the basic extensibility comes from. Okay, so after we have done the rendering part, that is, we render those parameters into the real running resource. The next part is that we need to orchestrate those resources. Because as I mentioned above, those components in application are not irrelevant. They are related to each other. For example, your WordPress application, your WordPress deployment might need to be run after the database is ready. So the database component should be set up before your WordPress is delivered. So that's how we orchestrate the application. We specify the dependencies between different components, and that will tell the application how those components should be orchestrated and delivered. And this is one way we can organize those components in one application. Except for the dependencies, we also have a very fine-grained control capability for the application delivery process, that is the workflow part. So in workflow, you can actually manually specify which step you want to use and how those steps are organized together. For example, you can firstly apply your databases until it is ready, and then you will apply the WordPress. So finally, you may want to also add some Slack message to tell you that the delivery process has finished. So that's how you organize the workflow to make your application delivery process more controllable and more functional. Besides the workflow part, we very similar to other known tools like Tecton or Argo CD, and we have very advanced capabilities for control the workflow part. For example, we can have some conditional execution, and also we can have some data passing between different steps. And also the workflow part supports parallel execution, so that when you have lots of components inside one application, it can be delivered with high performance. Besides, the workflow part is also highly extensible through the queue rendering templates. Instead of rendering those templates into resources, in the workflow part, we render those templates into actions or commands that will be executed by the underlying Kubevela controller. And the Kubevela controller itself provides lots of underlying functions. For example, apply one component or read some resources from the Kubernetes cluster or send messages through Slack. And the upper layer workflow step will be able to leverage the underlying functions and organize them and make them work together to produce higher level workflow steps for the application user. So the application user will be freed from carrying the underlying implementations, but more focused on what process they would like to execute. So depending on the scenario of application user want to use, there are different level of abstractions, and they can use any way to organize them. And finally, we also support the multi-cluster deployment. For example, if you want to deploy your engines into multiple Kubernetes clusters, the legacy way to do it is to copy the application, copy the engines configuration and apply them into different Kubernetes clusters one by one. But with the Kubevela application itself, you can specify the multi-cluster deploy strategies. For example, you can specify the topology to specify which clusters you want to deploy to, and the application will be able to deploy those resources into different clusters at the same time or in order. And this will help the users to keep those common configurations into one single file, so that the management of those configurations will be much easier and manageable. So if you want to make some updates, you do not need to go one by one. You just add it one application and it will take effect in all clusters. So that's how we do multi-cluster deploy with the application. And in addition to that, we also have some authentication for the deploy process. That means we reuse the authentication mechanism of Kubernetes, and that will let the user of application only able to deploy resources under its privileges. So if someone wants to create an application and deploy resources that's beyond its privileges, it will be forbidden by the Kubernetes API server. So the delivery process is authenticated and secured. And also the multi-cluster deploy supports all kinds of cloud providers. And also we even support edge Kubernetes, which might have some issues with the network connection, in which place we incorporate the open cluster management to support two different ways for the cross-cluster connection, including the pull mode and the push mode. And okay, so that's all for the application delivery part. So by far, we have been discussing about how Kubevela define application, organize resources, and dispatching them into various destinations. And also, after we have delivered those applications, we will be focusing on how those applications runs and how to manage them and operating them. Okay, so the first important things for one application is that how it manages different resources. One of the fundamental rule for the Kubevela application is that it is generally final state oriented. So when the delivery process has helped Kubevela application to reach the desired state, the desired state will be kept and will be watched as well. Once someone edits the resources and let it to be different from the desired state, Kubevela application will be able to find that and bring it back later. So this is one of the fundamental rule for Kubevela application. But also there are scenarios that users do not need this feature, and this feature can be switched off as well. Besides, the Kubevela application is also responsible for recycling all the resources it's dispatched. So once the application is deleted or upgraded, the outdated resources will be deleted as well. There are some cases the applications could share, multiple applications could share the same resource, and they will share the control of the resource and manage them in manageable ways. Yeah. Okay, and also Kubevela application has version control. So if you have delivered your application and updated it and many times, you can actually roll back to previous versions. Once you find that the latest delivery has failed, so you can actually view those history versions and find out which one is successful and go to the latest successful one. So that is a rollback action for the application. And also sometimes you might need to, you might want to manually publish your application instead of let the application publish itself once it's changed. So with the manual publish capability, you can edit your application first and commit those changes later. And for example, when the changes are not committed, you can actually use some like CLI commands or the UI to see the difference of the current version and the current spec of the application. And after that, you can make manual publish by specifying which version you would like to go. Besides, we also have observability for the application itself. This is achieved by integrating various community projects like the famous Prometheus and Grafana. And it is also reached by creating new component definition and trait definition itself. And also the backend, those Grafana and Prometheus can be integrated from Kubevela add-ons. And you can build them on-premise, and also you can reuse your cloud services from cloud providers like Azure or Amazon. Yeah. And also, after you have set up your infrastructure for observability, Kubevela application is able to use those traits and components to declare which way you want to use to monitor your application. So besides, we also have some basic observability capabilities from the CLI and the UI as well. Okay, as I just mentioned that you can create the Prometheus and the Grafana from Kubevela applications, and that's the Kubevela's ecosystem, and that's how Kubevela itself integrates with the third-party open source projects. So as the official repository, we have a repo on GitHub called Catalog, which holds lots of existing add-ons. And those add-ons are application templates, which is backed by Q as well. You can render those application templates into application and deploy those applications in the Kubernetes cluster so that you can integrate other open source projects like Dex or FluxCD as well. So these add-ons are actually organized by Q templates as well. And these definitions will help the existing application in the Kubernetes cluster to use the capabilities provided by that add-on. Okay, besides, we also have a lot of tools in Kubevela to help you to deliver your application under various circumstances, like using the Terraform controller to manage your cloud resource, and also use the cluster gateway to manage multi-cluster resources as well. Okay, after that, I would like to share a simple demo for Kubevela application that will show how we play the application and how we use it to handle some real scenarios. And it is a video recorded by Fog previously, and I will play it now.
Hi everyone, my name is Fog. I'm glad that I can give you a quick demo today about how Kubevela can work with application.
Linda, we can't see the video. We just see your PowerPoint.
Okay, so let me see. I need to share my screen. Yeah, can you see the video now?
Yes.
Okay, cool.
Hi everyone, my name is Fog. I'm glad that I can give you a quick demo today about how Kubevela can work with application, from deploy, manage, to observe. Let's get started. So let's start with a simple case. I have two clusters called local and product. I have already managed them with Vela command, so I can use Vela class list to show two clusters. And I want to deploy an NGX to both of the clusters. So here's my application YAML. The application is also very simple. There's only one component in the application. It's called NGX, and its type is web service. I also changed its expose type to node port so that I can access the NGX more directly. And I have this policy here called topology. In this policy, I specify that I will apply the component NGX to two clusters, local and product. And in workflow, I define how I can control the deploy process. So first, I'm gonna deploy the NGX component to two clusters. And after that, I will send a Slack notification to prove that my deploy is successful. Let's apply this application to the clusters. We can use Vela app command to apply the application. All right, the application is successfully applied. Let's use Vela status to check the status of the application. Okay, we can see that all the steps in the application is successful. Now we can also use Vela status / tree and detail to show the resource detail of the application. This command shows all the resources behind the application. So the first line here is cluster, and after that is namespace. You can see that all the resources in the application from different cluster and namespace. In this application, we have this NGX deployment in 2 clusters here. And also we can use this Vela status / endpoint to show the service address of the application. We can see that there are 2 services in different clusters. And the NGX is up. And in our application, we also send a Slack notification. So in my Slack, the bot also sent a successful message to the Slack channel. In Kuvela, we also have a very important part called add-on. The add-on system is one of the important parts of our ecosystem. We already have many powerful and useful built-in add-ons like Vela UX. The Vela UX is a dashboard for Kuvela. And I have already enabled this add-on, so I can use Vela status / dashboard to check its service address. We can see this demo NGX app here, and this is the app that I just applied. So in Vela UX, we can see more details of the application. For example, we can see the resource graph of the application. We can see that this NGX application will deploy to 2 clusters here. And in each cluster, there will be 2 resources. One is deployment and the other is servers. We can also check the logs of the pod. In fact, we have some default resource graph rules for the normal application. For example, we will define that after deployment, we will have replica set, and after that, we'll have pod. But if you want to create your own resource graph rule, that's totally fine with our queue interface. You just need to define your resource rules in the add-on, and when the add-on is enabled, all the resource graph rules will be applied. So that's more of deploy and manage part of Kuvela. We all know that after we have deployed the application, we still need to observe it. So in our add-on systems, we have this built-in observability add-ons for our users to use. I have already enabled them, so let's check it. This is the Grafana add-on application, and we can use its service endpoint to visit. And here's the Grafana dashboard. We can see that in the browser, we have this built-in Kuvela applications dashboards. Okay, we can check out the default namespace and our demo NGX app. So in the dashboard, we can see that the age of the application and some other resources here. If you want to check the deployment dashboard, we can click the link. And that's the deployment dashboard. We can see the memory and CPU or network here. But maybe that's not still enough. I want to know more about our NGX app. For example, the QBS of it. We can now change our application. We can add this trees here. So basically, this tree will collect logs from the std out and use this info to create another GraphNode dashboard so that we can see the QBS of the NGX. We can now update this application. And let's refresh the graph now. After refresh the dashboard, we can see that there are new kind resource in the managed resource called GraphNode dashboard. This is created by the tree that we just applied. We can check out the details. Now that we can see the QBS in the NGX. All right, so that's all of my demo today. Thanks for listening.
Okay, that's a brief introduction and the demo for the Kuvela. And actually, we have more information for the Kuvela. For example, we have done some load testing and have shown that Kuvela's controller is possible to handle thousands of applications under limited resources. And you can actually make some customized tuning to let your Kuvela controller to handle more applications under certain circumstances. And also here is a brief overview for the milestones of Kuvela. And you can see that since the March in last year, we have just released the version 1.0, at which time we only have the application. But after 1 year and a half, and we have developed lots of new features like the workflow, the value UX, and also the observability. And we are recently working on some new features for the workflow part and the observability. And we are making new minor releases every 3 to 4 months, I think. Yeah, also, and there are lots of users that are using Kuvela. And as far as we know that there are some areas that uses Kuvela. There are multiple companies using Kuvela in those areas, like the banking area and also the car manufacturers. And also some cloud providers uses Kuvela to build their PaaS platform. And also there are some game companies. So as far as we see that some high-tech industries likes Kuvela a lot. And also here is a chart for how Kuvela community are evolving. And so the Kuvela, there is a lot of attractions to Kuvela recent days. And also we are responding to all kinds of issues and pull requests as fast as possible. And we have over hundreds of contributors from various countries. And for those thousands of issues have been created, we have solved most of them. And besides, we also have the bi-weekly community meeting, which is on Tuesday. And also we have recorded each community meeting and posted on YouTube. So actually there are also like 30 times recordings on the network, and which introduced the progress of Kuvela bi-weekly. Yeah, so that's all for today's sharing. And here is the GitHub repo for Kuvela. And also we have our Slack channel. And for, I think for Chinese users, more users would like to use StingTalk. So here is the communicate tools that can reach out to the Kuvela team. So I think that's all for today's sharing. And if there is any questions, you can just raise it here and we can discuss it and answer it.
Very cool. Thank you so much for taking us through that. I have a bunch of questions and I'll try not to monopolize time. but I'm excited. So one question I have is, it sounds like one of the central premises of this application object is that everything for a microservice should be defined in either that application object or the associated Q files for that X definition. And I'm wondering if there are tools that you use. It seems like it could get really big, like a really giant file. I'm curious if does it get really giant? And second, are there tools that you use to manage that complexity?
Okay, so that's actually a very critical question, and also we are facing it, especially in real production environments. Some of the users are also raising the same question here. So actually, it is true that the applications could grow very big, especially, for example, when we build those add-ons. Some of the critical question is that there are CRD definitions, and those definitions are usually very big. And also, at last, you see that we use a component to model the Grafana dashboard. And the Grafana dashboards, the behind data is really big, like thousands lines of codes. So if you put them all into the application, it will be really, really big. But there are two ways to solve it. So the one way is that we leave those complex things in the Q files, so those definitions. So those large files will only be handled by the system operators, and the application user will not handle it directly. So they will only use those exposed interfaces and definitions, and the definition itself can generate lots of codes under the application itself. And another way to handle it is that we support special component called ref objects. The ref objects can use the URL to refer to some resources outside the Kubernetes system, for example, from your GitHub repo, and so that you can place those large files into some repository, and you do not need to face them in the Q files or the application, and you can use the ref links to help you handle that. But as for the large files itself, I think usually if the large files contain multiple parts, personally, I would suggest separating them into different components or even different applications. But as far as we see that there are users that in our community that have large applications, and the large applications will truly cause some storage problem because the application is a CRD, and the recordings like the application revision or some other related CRDs could be really large. So we actually, to handle the performance part, we also have some use some compression algorithm, or like you split those storage to handle the performance problem. So the size of the application or the resources are actually something we are looking into and continuously improving it.
Maybe Justin is asking about the tool set, how we manage Q files. Am I right? We have provided several commands such as vala vet, vala def apply, and vala def edit, and so on. And we also have lots of commands to manage the version, rollback mechanism, and such as a version management mechanism. So we really provided the tool sets to manage the Q files.
Yeah.
Awesome.
So just for some additional information, so if as for the managing your definition and Q files, you can either use the Vala command line interface to help you to manage those things. In the CLI part, we do some parsing and some some help commands to help you to manage those large files. And also on the UI platform, which is Vela UX, you can also viewing those definitions that in your browser, which can makes it might be better for editing. And besides, so Kuvela itself, we are trying to make the definition as close to the Qlang community as well. So actually, we are recently using the latest version of the Qlang. So one of the way to manage those definitions and also the add-ons, all things in Kuvela that's related to Q, we are making it possible to use the native Q tools to do the formatting and the syntax check. So so therefore you can leverage the Q tools instead of the Vela tools to help you to manage those things as well.
Cool. When you upgrade your, so I think that in your application definition, each component has a type, and that type associates which X definition gets used to render the thing. Is that right?
Right. But multiple components can share one type together. Yeah.
Yeah. And so if you were to publish an update to the type, web service type, how do you manage upgrades of that across a cluster?
Okay, so the definition itself, as you said, for example, the web service component definition, the definition itself only lives in the control plane. It will not be multi-clustered. The resources will be dispatched into different clusters. So there will, as far as we have seen, there will be no sync problem for different definitions across clusters because only one single hub cluster will have those definitions. So as for the updates, that will be another very interesting question. That's how we use application revision to store the history things. For example, when you deploy your application, the application revision itself will not only store the application, but also store all the related definitions in the revision, so that when the outside definition changes, the application can always have history tracking for the definition that it uses in the past when it delivers the resources. So that's also a problem that will cause the application revision goes very big. But in this way, you can have a snapshot or a very static storage for the history version of your definition and your application.
How do you, like, if I were to push a new like XDEF, does that apply to a whole cluster all at the same time, or like how do you manage that rollout? Does that question make sense?
Yeah. So as you have seen that the application and although the application itself can manage resources across different clusters. So I think that's the delivery part. But for the rendering part, all the rendering process we have done are on the single hub cluster. So the Q part will only live in one cluster, and also the definitions will only be used in one cluster as well. The remote clusters will not interact with the upper layer definitions. The X definition will not go to the managed clusters, but the deployment will. The service and ingress will. Yeah.
So you change it and then it triggers a deployment.
Yes. So yes.
Not really. Once an application has been deployed and running smoothly, it won't be affected immediately when the definition is updated. It will trigger the update when the application spec has changed. So any X definition change won't affect the running application, just affect at the next deliver process.
Yeah, so I can give a example for that. For example, if you have already delivered like 100 application in your cluster, and you want to try to edit the definition, since though the 100 application has been successfully delivered, and the edit to the definition itself will not directly trigger those 100 application to be redelivered. They will stay there and not changed. But the next time they are updated, they will use the latest definition.
Awesome. I'd like to make sure other folks have time to ask questions also. Does anyone else have a question for the Kubevela group?
Yeah, seems you are very interested with the rendering part with Q, and actually we are continuously communicate with the Q team because we are using some latest features, and Q also have some bugs for the latest features. So we are having meetings and upgrading those underlying infrastructure as well.
Awesome. Well, I super appreciate y'all coming by and giving us a talk about Kubevela. This has been super interesting and very very tied into the things we do here on the interoperability group. Yeah, so thanks so much.
Yeah,
Appreciate you coming by.
thanks to you as well, and we are very happy that we can have chance to share our work with other community people. Yeah.
Perfect.
It would be very interesting to hear responses, and if you have further questions, it is free to raise it either on Slack or on GitHub issues.
All right, well, thanks everyone so much.
Thank you.
Thank you.
Thank you, Justin.
Thank you. If you, I'm not sure, Jianbo, if is it okay for us to share the materials or the PowerPoint slides to the to other community?
Sure, we can convert it into PDF format and share it.
Okay, so because I think there is some material that's contained in the presentation, but I give it very fast. So if you want to have some detailed information, you can go back to the slides. And I think it will provide more information for that. Okay, great. Thank you, guys. Goodbye.
Bye.
Bye.